session. All right. Good morning, everyone. Welcome to the second class of Introduction to Artificial Intelligence. In the first class, we covered some information about the exam, about the assignments. We also covered a few. Then we went through a bit of statistics on artificial intelligence, which is important for us to share. Those statistics were taken from a report called Stanford AI report that was published in 2021. There's another one out in 2023. So what I will do is I will make another presentation out of that report, and then we will have another class on that one. So we'll get an idea how things have changed from 2021 to 2023. But that class will come afterwards. So today we are going to dive into artificial intelligence. We're going to discuss what really is artificial intelligence. Where does the word artificial intelligence comes from? What is the difference between intelligence and artificial? And we're going to separate these two words, and we're going to discuss those as well. And every 10 minutes or so, I'm going to jump on the chat. So if you have any questions, please ask in the chat. All right. Wait. So every presentation will be recorded and it will be put on Canvas. So take a look at Canvas and see if you missed the previous one. Just take a look at the previous lecture and you can find it over there. Okay, for us to be able to understand what artificial intelligence is, we need to talk about the word intelligence, and we need to understand what does intelligence mean to us, or what does it mean to you. The word intelligence changes from culture to culture. The understanding of the word intelligence changes from culture to culture. If you talk to PhDs, or if you talk to people who have won like a Nobel Prize, they would have a different meaning of the word intelligence. And if you talk to a regular person as me, as you, we will have a different meaning of the word intelligence. And then we have another thing called the IQ test. And IQ tests change from person to person as well. Yeah, okay. Let's see. Yeah. So, I mean, every person would have their own understanding of the word intelligence, and they would define it. Every person having a different IQ will look at intelligence in their own way. And some people might be smart when it comes to textbooks definition of being intelligent. But that doesn't really mean that they are not intelligent. They might be intelligent, but they don't really fall under our standards of being intelligent. Like our standards of intelligence are mostly like we have defined ourselves, go to the university, go to the school, go to the university, do this and do that and do that. And if you do this and that, we consider you a smart person. But that's not really the universal definition or understanding of being intelligent. So what I'm trying to say is that the context and the word intelligence changes from person to person, context to context, country to country. And yeah, everyone has their own understanding of what intelligence is. But if you look at psychologists and how psychologists would define intelligence, so they have identified three big areas. And if you are able to do these three things well, then you are an intelligent being. And those three things are if you as an individual have the ability to learn on your own, if you have the ability to solve problems without requiring some external input, external effort, and if you can see the problems and recognize some pattern in those problems, then psychologists think that you are an intelligent being. And if you look at that, if we take these three major points, and if we apply them to every living creature on planet Earth, then every living creature is intelligent. They have the ability to learn, they have the ability to solve problems, and they have the ability to recognize problems. So on the very base level, this is what intelligence is. This is what defines an intelligent being. Now, let's jump on to artificial intelligence. Now that we have discussed what intelligence is, how can we transfer it to a machine-based entity? So we have spoken about biological entities and we have spoken about how they are intelligent. But if you take the same concept of intelligence, the one we defined earlier, and that's the three main things: the ability to learn, the ability to recognize problems, and the ability to solve those problems. And if you put these three abilities in a machine, and machine can be a hardware machine, a software machine, that would be an artificially introduced intelligence. I see the spellings of artificial are wrong. But you see my point? Like, that's the difference between a human and a machine. Like, if we create a machine which starts to behave like a human, not like pick things and drop things and this and that, but if a machine is able to recognize a problem, solve this problem, and ability to learn from its surroundings as well, then we have created an artificially intelligent life being. And that machine would also, that entity or machine would be able to make their own decisions and and to take actions on its own will. Now, that is the biggest difference between a simple software program and an AI-based program. In a simple software application, what we do is we write a set of instructions. We say, like, okay, if a user presses if a user presses the keyboard integer st, you have to output t. If it's a u, you have to output a u. And then we define the hard code, like if this, then that, if this, then that. We have all the set of instructions. That is not an intelligent software application. That is a simple software application, which should be based on the rule set instructions. But when we train an application and we tell the application, like, you have to pay attention what the user is inputting, or the answer can either be u or a v or a w or x or a y, that would be an AI-based application. Because then the application can think on its own. The application has learned from previous experiences. The application can make a decision not based on what we think the application will produce the output, but what the application itself thinks this is the right output which will come out. Okay, another way to describe this would be that a software that solves a problem without any explicit human instruction. Now, this is also a biggest difference between normal software applications and an AI-based application. And the thing is, like, the normal software-based applications, they wait for human instruction, and we know what the output will be because we know what the input will be. And if the input changes, then we know exactly what the problem can happen. But in an AI-based application, we don't really have control over the output. We have control over the input. We know what data is being fed into the machine. We know how we have trained the machine. But since the machine learns on its own and it does its own calculation, we do not really have so much control over it. It's the same thing as being any intelligent person. You are talking to another intelligent being and you tell that person, okay, this is a problem and you have to solve this problem. And the person you would want the person to give a solution, the one you want, but there are many solutions to that problem, and the person might be able to give you a problem which you least expected. And that's the same thing with AI applications, that you make a software and you just don't know what kind of output it will give you. You have an idea that it can give me this or that answer, but it might give you an answer which you did not even think about. And that's the power of AI, and that's the problem with AI as well. And that's the thing which everyone is afraid of. Like, we can't control AI. Okay, this is a lot of text, but I'm just going to go quickly over it. So So let's compare, since most of you are programmers, you come from a software development background, you need to know what is the difference between conventional programming and AI programming. And when I say conventional programming, this is the standard programming we do today: Java programming, C#, Python, C++, so whatever. And then you have an AI-based programming, which is a totally different kind of field altogether. So let's start with the statement number one on the conventional programming. So what happens in conventional programming is that when we look at the problem for conventional programming, we look at the problem and we're like, okay, we know what the problem is, and then we design an algorithm around it. However, in an AI-based application, so the focus on the conventional programming is the algorithm. We have to think about data structures. We have to think about how the RAM will be optimized. We have to think about our algorithm itself, and then we design the application. In an AI-based application, we look at the problem, but we don't design the algorithm around it. What we do is we know what kind of output we want to achieve, and we look at the output, and the output can be as simple as, okay, is it going to be a true or a false? That's the output we want to design. And then we start looking at what kind of data we will need, what kind of algorithm will we have to what kind of algorithm we have to choose to work on this application. So that's why AI becomes a bit more complicated. It's not just programming, it's more about data as well. In conventional programming, you could say that a programmer has more control over their application. Since they write all the instruction sets, they know exactly what's going on. If you want to debug the application, it's very easy to debug. You go from line to line and you see how it went, what the problem was. In an AI application, we don't have the same context as, you can debug an AI application as well, but the model itself, you cannot debug the model because the model itself is trained on so many parameters, so much data, that you don't really know what's going inside the model. So you train the model on your own data, and then you're like, okay, we think it's producing this output because of this and these reasons. And that's one of the reasons there's a concept called explainable AI. And that concept says, like, when you create an AI application, you should be able to explain how you reach that desired output. And the problem with AI algorithms is that there's a very huge community which says that we have no control over our AI algorithms. Sorry, they don't really say we don't have no control. They say, like, it's very hard for us to explain what we have achieved. And then there's another group which says, like, it should be no problem for you to be able to explain your algorithm. Look at the data you are using. Look at the model you have programmed. But explainable AI is hard. To be able to explain how your algorithm achieve the result, that's a very hard thing to do in AI. Okay, the third thing is that, as I said earlier, you have an instruction-based thing. So in a normal software application, you have a set of instructions, and then the software has to follow those instructions. In an AI-based application, AI applications usually use a technique called search and patterns. So they look for different patterns. So let's assume you are working with an image-based AI application, and you want to find a particular person, or you want to find cats. You have a huge amount of data sets of cats and dogs, and you want the algorithm to do something very simple. You want the algorithm to identify all the cats from all the millions of images of cats and dogs. Now, the way the algorithm works is that it tries to find patterns in all the images. And a cat has a specific pattern. It has a specific kind of ear. It has a specific kind of tail. It sometimes has fur on its body. Most of the time, it has fur on its body. There are a few cats who don't. But this is also a pattern for the AI image, for the AI algorithm. Like, it will identify a pattern, and then it will define that pattern to be associated with an entity called a cat. And for a dog, like dog and cats are similar when you look at from a pattern point of view, but you still have some differences between the two. Like if their mouths are open, the dog's mouth will be much, it will have like teeth which are coming out as compared to cat. A dog will be in most of the dog images would be much bigger in size as compared to the cat images, and so on and so on. So the way AI works is it tries to look for those kind of patterns and then tries to identify, okay, this is the pattern I've identified. So all these images having the same kind of pattern belong to the cat category, or they belong to the dog category. Remember I told you about this sexist algorithm which Amazon created, and Amazon went on to create this algorithm which was mostly like, so for those of you who did not hear about it, Amazon started working on an AI-based algorithm, and they were getting a lot of applicants. It's a huge company. They get a lot of applicants, and they have to sort through those algorithms, those applicants. And they made an algorithm which was sorting to, which is the initial screening. And what the algorithm did was it looked at all the CVs, and then it sorted out like good candidate, bad candidate. And what they found out is that the algorithm was always prioritizing men in those applicants. And when they tried to look into it, why was this happening? They found out that historically in Amazon, they were mostly men who were hired, and they had a bigger proportion of men. They took away, so what they did was they took away the obvious things which would define an applicant as a male applicant or a female applicant. And then they took away the name, they took away the gender, they took away the date of birth. Yeah. So the most obvious things which you can take away, they took them away, but still the algorithm kept on predicting more male dominated CVs, and they were like, what's really happening? So what happened over there was that the algorithm found a structure, a pattern inside the CVs. And what happened was that, so this is something is kind of, which came out from that study. So I'm just quoting as is, it's not really my opinion. What they found was that male applicants had a tendency to exaggerate on everything they had done as compared to female applicants. And AI picked out that pattern. So every CV which was a bit more exaggerated, AI kind of associated in itself that this is a special kind of category, and I should always value this CV more. And even though the makers of the algorithm did not intend it to be a sexist algorithm, and they took everything away, the algorithm found this on its own. And this was a kind of gender identification which wasn't planned, and it was highlighted by the algorithm. So this was something which was totally out of their control. And what they did was they shut down the whole project because they didn't really know how to control it. So that's how AI applications work. They work on a technique of search and pattern matching. Then the fourth point is that, okay, we spoke about this one, explainable AI. It's easy to explain simple algorithm, but hard to explain an AI algorithm. Last point is very important. So when you're making a simple application, software application, your focus is always on the algorithm itself. And you're like, okay, which algorithm should I use? And how should I make the application? Which language should I use? And all your focus is on the application. You start with the language, you go on to the framework, you go on to data structures, and you build your application. AI works the other way around. In AI, of course, you also have to look at the frameworks, you have to look at the language selection libraries and all those. But then in addition to the algorithm, so you do the same part of the algorithm, but you also have to do an extra part, that is the data you need to train the algorithm. And data is the most important part for AI. If you don't have any data available, you cannot build an AI algorithm. And that's one of the reasons why OpenAI has used billions and billions of parameters, and parameters is actually data itself, to train their algorithms, and they have used a lot of money to train their AI algorithms. Okay. This was kind of common in we right now, I think we are more educated about artificial intelligence. We know how AI works, but a few years ago, most of the people, it was still a new thing coming in, and people were like not really aware how what really AI is. So most of the people, when they were writing like if-else instructions, they were claiming that their algorithm is also an AI algorithm. And you, being the participants of this course, should be able to distinguish between a simple application and an AI-based application. And that is my aim as well. Like once you're done with the course, you'll be able to clearly see the difference between two applications and see like, okay, if someone is selling you an application, is it really AI-based or is it just simple application, which is based on rule-based processing? Okay, this image is really cool. This is not really my image. I copied it, downloaded from, somewhere. I think I have a reference where I downloaded it from. But you need to understand, so what this image shows is like, okay, you have the branch of computer science. You have computer science, which is really, really big. You have different things going on in computer sciences. Then AI is also a branch of computer science. It's not a separate thing from computer sciences. It's actually a part of it. So if you see all the way to downside on the left-hand side, you see machine learning, computer vision, image processing, natural language processing, and so on, robots and so on. So some people assume that AI is like something new, something different from computer sciences. It's not. It's one of the branches of computer sciences. So we have had a lot of industrial revolutions in our times. One second. Okay. So we have had a lot of revolutions in our times. In 1784, the first revolution which happened, which actually, so what really is a revolution? A revolution is something, when it happens in your lifetime, it has happened before, it's going to happen again. It changes the way we work. It changes our society. It pushes our society so much forward. And we have identified 3 major events in our previous history which actually pushed us forward. And the first one, which we identified, happened in 1784, and that is called the steam and water power revolution, which we assume would replace all the humans and animal powers, and machines will come in and take over everything. Machines did come in, it helped us a lot, but it didn't replace humans and animals altogether. Animals, yes, they replace a bit of animals. The second biggest industrial revolution which pushed us forward was in 1870, and that was when electricity came out. And then there was electricity, internal combustion engines, airplanes, telephone, cars, radio, and there was a mass production of all these things. And everything happened because electricity came out. The third biggest industrial revolution was in 1969. And we're talking about automation. And one of the reasons why automation happened, because you had like a lot of electronics were designed, a lot of chips were designed, and then internet also came out after some while, not really at that time, but then it also helped move us forward. So what people who, philosophers and scientists are saying, like, we are actually living through the 4th biggest industrial revolution, and they are calling AI as one of the biggest industrial revolution which ever has happened. We've been talking about driverless cars, but that thing has actually died out on its own. But we're talking about smart devices connected with each other. We're talking about AI on your small devices can help you do things. We can talking about there's a lot of excitement around LLMs now. This excitement has been there for the last 3 years, and I have not seen this excitement going away. Like there's always an up curve and a down curve of every technology, but for the last 3 years or even more, I've seen a lot of excitement around this being the fourth and the biggest industrial revolution ever, which will have an impact on our lives, that it will change the way we work, change the way we interact with each other, change our existing devices, make them more smarter, and this will push us more forward. So time will tell if this was the right revolution or not, or this is also like something which died out on its own. But if this happens, if this is the revolution which people are saying it might be, then this is a really exciting time to be alive, because we're actually going and we're actually experiencing that revolution taking place. And if you look at big companies and how they are investing, what kind of efforts they're putting into it, the major CEOs of the major tech companies are actually already calling it the fourth and the biggest industrial revolution. They're investing a lot in AI-based application. The whole base, the whole stack is updated with AI application. You might not even know that more than half of the applications you use already have some sort of artificial intelligence embedded into it without no one knowing that it's actually AI behind it. Yeah. So if you look at the history of AI, you need to know that the efforts to create the first intelligent machine, they started as early as 1642. So this is even before the Industrial Revolution. People were like, okay, we need to start working on something more intelligent. And yeah, that thing was a mechanical calculating machine. Not really AI, but okay, we need something intelligent, which is better than how we work today. Then there were more things which happened from 1642 to until now, but I took away most of the points because they were not really that important. But I think the important one which needs to be identified as a Turing test was introduced in 1950. So what really is a Turing test? I have another slide on it, so I will explain Turing test in 1950. But it wasn't until 1955 that we coined the term artificial intelligence. And again, the spellings are wrong here, but I will fix that afterwards. So it was from 1955 and onwards that we actually gave it a name, and we were like, okay, this is what we need to achieve, and this is how we need to go forward in the field of artificial intelligence or intelligent machines in general. If I do have an image on what happened. So you have 1955, then it's 1955 onwards, I have history. So from 1956 to 74, you had a lot of upscale, a lot of AI research was done, government funded came in, a lot of solutions came in, but we didn't have anything concrete coming out. So then in 1987, you had like an AI winter, and people were like, okay, it was a hype, it died out. And it died out until 1993, 6 years. And then from, okay. Oh no, I'm doing it wrong. Okay. 1974 to 1980. Sorry, I did it wrong. 1955, AI was formed. 1956 to 74, golden years of AI. 74 to 80. Okay, overly high expectations and limited capacities. Okay, so there was the first AI winter in 1974 to 1980. Some people are predicting this is what's going to happen now after Chat GPT, that we will also jump into that phase where it will be a downturn for AI. Yeah, but we'll see. So 80 to 87, knowledge-based expert systems. Okay. And then 87 to 1993, we had the second AI winter. We didn't really see something happening. 93 to 2011 was a very interesting time because then we had a lot of focus on technology. We had chips coming in which were more powerful. Internet came back, and the optimism about AI also came back. And 2012 to today, you have seen like exponential growth. Yeah, why is that exponential growth? So why is it that from 2012 to today we have seen like huge and exponential growth of AI? And the reason that has happened is that we have access to much more data than before. We have the internet. You make a profile on Facebook, you make a profile on Twitter, you make a profile on all social medias, and they all start collecting data about you. You have your phone, which collects your data, your device, your watch collects your data about you, your smart home speaker collects data about you. Every single smart device collects data about you. We have access to all that data, and then AI algorithms have access to that data. Now, the second thing is cloud computing. What is cloud computing? Cloud computing is basically when you, how should I explain it? So when you create an application, you need to host this application somewhere. Like Zoom, the way I'm communicating to you right now, where is Zoom hosted? How is it that I am able to communicate with almost 125 people through this application called Zoom? Someone needs to keep Zoom running all the time. This application, and it turns out that this application Zoom is being hosted by Zoom, the company Zoom. So we don't have to learn about, we have a URL which we need to click, but Zoom makes sure that Zoom service is up and running the whole time, and that's being run in the cloud. This is called cloud computing. All the computing is being done in the cloud. If you have an iPhone, if you have an Android, all of your data, you're probably using Google services or Apple services. All of your data is being backed up to Apple Cloud or Google Cloud, and your data is backed up over there. All the services also go on the cloud. So the cloud, I don't know why they call it a cloud, but this is a processing power which you can rent on demand, and all the applications, they use cloud for that processing power. Now, why was cloud computing important for AI? Before cloud computing, what happened was that AI algorithms require a lot of power. So every time you wanted to work with AI, you had to buy a specialized equipment for AI. Now, you need to buy a computer, right? Computer has to have a CPU, memory, a RAM, and then you need to install Windows on it. So you have to pay for Windows or Linux or everything. So you have to pay for those basic elements as well. And then to be able to run an AI algorithm, you need to buy a GPU because the GPU is very powerful. So people were looking at an expense of at least 20, 30,000 Norwegian kroner just to start working with AI. And if you are a student, or if you are a researcher who just wants to experiment with AI, you can't really afford that much money to just start working. So then it became out of reach for most of people to work with AI. But then cloud computing came, and cloud computing came with the promise like, okay, we will provide you, instead of buying the equipment, why don't you rent the equipment from us through the cloud? Microsoft came out, Amazon came out, Google, Alibaba, a lot of cloud companies came up. So what they did was they bought a lot of hardware, and then they rented out the hardware to everyone to use. And then AI hardware became so cheap. Like instead of you spending 20,000 or 30,000 Norwegian kroner to buy an AI specialized hardware. You can just go to one of those cloud computing providers, use that computing, the whole sophisticated AI hardware for $2, $5 per hour, and that's it, and you're done. And then you can do your experiment, and you would have spent like $5, $10, or $20 or $100, a fraction of the cost which you would have spent by buying the hardware. So from cloud computing, you can rent hardware from the cloud providers, and you can rent the best of the best hardware for a fraction of the cost. And when that computing power became available to a lot of researchers, a lot of students, a lot of companies, they found it easier to work with AI. And then the chips have been becoming powerful. You have, we had GPUs, and then now we have CPUs who are becoming strong enough to give us the power to work with AI. And then this is IoT. So IoT is another field which says like Internet of Things. What it basically means is that it's a smart device. Every device we are creating is a smart device. And when we say a device is a smart device or a simple device, what we mean is that if your device is a smart device, it is able to connect to internet and transfer data from one point to the other. And almost every device we buy nowadays, electronic device, has a way for it to connect with internet. And if you can connect it with the internet, or even if you can transfer some data from it, it's a smart device. And if it's like your watch is a smart device, the one you wear on your hand, that can transfer data. Your phone is a smart device. Your speaker is a smart device. And when you have more of these smart devices coming up and they're able to transfer data, we can learn from them. And that also helped us succeed there. So all of these things kind of fuel the existing fields, which are machine learning, deep learning, and natural language processing. And that's one of the reasons. It's not really one thing which pushed AI forward. It's a collection of many things which happened from 2012 to today. Okay. I'm wondering if we should take a break, 15 minutes break. It's 12:10. We should take a break at 12:15, but let's take a 15 minutes break and we come back at 12:25. All right. I'm going to pause recording now. And if you have any questions, take it on the chat. Okay, so we are back. So let's see. So what's now this thing says like, can AI exist on its own? And apart from OpenAI, which is actually a company which develops AI models, can you name a company which exists on its own? Like you have a few coherent and these things which are designing AI models, LLM models, but would you call Google as an AI company or Microsoft as an AI company? Would you ever call them? And the reason I'm saying this is because if you think about it, if you think about how many AI companies are out there, and almost every company right now has a name of AI in front of them. They're not really an AI company. An AI company is an OpenAI company. OpenAI is actually a company which is purely developing AI, and they're selling AI to others. But if you look at Google, Google is not going to call itself Google AI because Google has a vast range of products. Ruter, the transport company in Norway, will never call itself Ruter AI. I will never say like we are an AI company, because we all use AI to help us succeed in other areas. So be careful when you look at companies which call themselves AI companies. Take a look at what they are developing. There's a company called Coherent, and they actually are an AI company because they develop AI models which will be used by other companies. But there's a huge trend that whenever there's a huge there's a huge huge demand for AI technology, a lot of companies will start calling them AI companies. And that will have an adverse effect because there are people, you and I understand what AI is, but there are many people who do not understand the whole concept, and they get fooled. And it also has a very bad financial effect that when some of these companies go to stock market and they are able to convince investors like we are investing in AI, a lot of people will invest in those companies just looking at their name. Like this is a trend. Everyone is talking about AI. This company has AI in its name. And in reality, they're not doing a lot of stuff on AI. So, so what I'm trying to say is that what AI does is that it helps other companies in doing their job in a better way. So you have a voice recognition system and you have intelligent searches in AI assistants. So the way you sell the product is not really an AI assistant. It's actually a smart speaker. And the smart speaker, you can talk to the speaker even though it uses AI. It's not really an AI speaker. And then translation services, you go to Google Translate. How many times have you used, I don't know if you use Google Translate. I use Google Translate a lot. But how many times have you gone to Google Translate and Google bombards you with this information saying, our AI algorithms have done this and that? They don't do that. Even though the whole translation service is built on artificial intelligence, you as a user of Google Translate will never see how much AI is being used in the backend. So please don't sell your service. Take a look at what you are going to sell. And if it's really an AI thing you're going to sell, call it an AI thing. If it's not an AI thing, call it something else, call it what you're going to sell it for. Okay. So it's important to take a look around yourself and see how many things around you actually have AI built on them. Now, this calculator, some people still use this kind of calculator, does not have any AI built into it. It has a lot of complex mathematical calculations, but they are more instruction programming. So this, we can say this does not have any AI into it. A camera, this is an old camera. So these cameras don't really have any AI built into them. But on the other hand, the newer version of these cameras, which you install in your homes, which exist on your phones, they have a lot of AI. But this camera is a very cheap camera. You can get it for 20 US dollars, 200 Norwegian kroner. It's AI is becoming as cheap as this, embedded on a hardware. It's accessible to everyone. And then if you take a look at chips, there's a lot of chips being designed, and some of the chips already have AI installed on them. This image actually is an extension to the camera image I showed earlier. So this is the camera, and this camera might have chips like these, and then you have the application built into the chip. The best thing about these cameras is that these cameras don't talk to any server. So everything is installed on the camera itself. If the camera wants to identify a person or an animal, this is something which is programmed inside the camera. And we have come so far ahead in the field of AI that we have made these devices more intelligent, and they don't even need to communicate with the server. They can do it with a lot of processing power built into them. Yeah. Do you think iPod has any AI in it? I don't think there's any AI in iPod. But I mean the iPod over here is also the one from 2012. So okay, perhaps I'm saying the wrong thing. The most recent ones might have a lot of AI in them. Okay, so there's a comment that they actually do have AI. They have an AI type song suggestion called Genius for a while. Yeah, that's true. Thank you. So how many have you tried those self-driving cars, the cars which drive on its own? And okay, not so many are replying, but that's okay. We don't really know how to correspond or reply in this Slack thing, but in this Zoom thing. But um, if we talk about self-driving cars, and if we say like how self-driving cars have evolved, previously we're talking about cars which would be driving on their own, and you have San Francisco as one of the major cities, or I don't know if it's San Francisco or Texas, which actually allowed self-driving cars to operate over there. But those are taxis. So you sit inside a taxi and it will drive on its own. But you don't have to go so far to look at self-driving cars. You can, if you have bought a car in the last 2 to 3 years, chances are there is some sort of self-driving technology built into them, and they can drive on their own for a very short period of time, for a few seconds, and then you have to take over. So there is some self-driving capability in the cars now as well. And then a lot of AI is present in image and video analysis. We use image, we interact with images, we take pictures all the time. As soon as you take a picture, your camera already tells you where your face is and puts more light on you. There's a lot of AI being used over there. As soon as you upload your picture on Facebook or some other social platform, it knows who your friends are, and it will try to automatically tag them and know, yeah, okay, this is the picture you were already associated in. So, and I think there's a new feature in most computers that using the camera, it can detect if you are the rightful owner of the computer. It will unlock it for you. So what I'm trying to say is that AI is embedded into things we use on a daily basis around us. Okay, so a question which I received on chat was that does a car which maintains velocity and distance to the car in front by itself count as a self-driving car, especially when it reads the signs and alters its speed depending on that? But these are two things. So if there's a car which maintains the velocity and distance to the car in front by itself, that is not considered as a self-driving car. Sorry, it is a self-driving car, but it's not an AI-based calculation, because you have a sensor, and the sensor tells you, most of the cars, the way they work is they have a sensor in front, and they tell you how far the car in front of you is. And that's a very distance-based calculation. There's no AI involved. However, when it comes to reading the signs, and the signs is where when the car is actually taking pictures of the signs around its surroundings, that's where AI comes in, because then you have to process the image and try to find out what's on the sign, and then you make a decision based on that. I might be totally wrong, but I mean, this is how I think a self-driving car would work. I'm not an expert at self-driving cars, but I think this is how it should work. It will be working. So, like, I was also one of those persons who bought like a voice assistant speaker, and I was excited about it. And then I found out how amazingly stupid it is. It doesn't really work. And the only thing it actually tells me is the time. And I'm just amazed how much effort was put into those smart speakers. And the only thing they're good of is to play the news, to tell the time, or to play the songs. And that's one of the reasons why Amazon now has decided to shut down its smart speakers division and reallocate resources somewhere else. That's a smart move. But these assistants came out with the promise of a lot of AI power. And yeah, they had some AI power, but it kind of lacked the basic understanding. the initial version of chatbots were also very irritating to use. I ask almost every presentation I go, I ask the audience how was their experience of working with the chatbot. Now I'm talking about chatbots. This is before OpenAI came in, before ChatGPT came out. And I'm talking about chatbots which are on support services, which if you go to a bank, they have a chatbot which pops up and asks you questions and you have to talk with that one. And of all the presentations I've done, I've asked people like, what is their experience of interacting with a chatbot? And everyone was extremely frustrated by the experience of a chatbot. No one enjoyed it. But the funny thing is, you have a huge population which does not enjoy interacting with chatbots. They don't want to have a chatbot. But still, there's a lot of investment being done on a chatbot. There's like, even inside Norway, there are two companies which have almost $1 billion kroner valuation because they are providing chatbot services. So I fail to see, like, the users don't enjoy it, but still there's a lot of demand. So what is the missing link here? The users need to enjoy this experience, but they don't. But when I was working in the tax office, Skatteetaten, and we did a test over there, we found out that people who were young, and by young I would say like up to 40 to 45 years of age, they didn't like using chatbots. But pensionists, people who were already retired and they were living home and they had a more relaxed life, they did not complain when interacting with chatbots. So we did not study more why it was like that, but this is how it was. I should have another slide on it because then there was a time of ChatGPT, and ChatGPT came out and everyone started to enjoy interacting with ChatGPT. And there's a new business which came out of that one. So companies who actually use ChatGPT-based LLMs, people actually talk with them more. Right. Another example of AI in our daily lives is email. We are used to working with inboxes, and we have spam, and a lot of messages goes into spam. And spam is one of the early examples of AI integrated into our email services. And we didn't even know that there was AI behind it, but there's a lot of calculation being done on to identify if a message is spam or not. And the most simple ones which I know are that if you're sending an email to a friend, and if you write everything in caps, like if you want someone's attention, and if you write like pay attention, or like just like a simple sentence, but you write it in caps, a spam detector will actually highlight that as a spam email. If there's a lot of spam on the rise right now, that you get a lot of calls, or you get emails from spammers who write the whole text in English, but they translate it using Google Translate or something else in Norwegian language, and then they send like spam messages to people like click here and pay and blah blah blah. And what these spam algorithms do is they are able to detect that the grammar in those emails, in those messages, is also very bad, and they identify like, okay, if the grammar is wrong, it's a spam message. Okay, and then I think someone actually has a microphone on. Could you please turn it off? Thank you. Yeah, and then there's a tool called Algorithm Checker. So what happens is that this is something which OsloMets also uses. So when you submit your final report or you submit your final project, we run it through a Algorithm Checker tool, and it does an analysis, and it finds out, okay, there was spam identified in this one because this is similar to the work done by 1001 student, and we should take a look at that one. A lot of AI is being used behind those kind of tools as well.
And then something you use on a daily basis is Google Maps, Uber Maps, Apple Maps, and all kind of maps. They have a lot of AI built into them. Router is also, do you also have an app called Router app? And we are also integrating AI into it. So you'll see that as well. Okay. This is one of the biggest examples of AI which we interact on a daily basis. Most of us have a social media account. We are either on LinkedIn, we're either on YouTube, we are on Twitter, we are on Facebook, TikTok, and Snapchat, Instagram, blah blah blah. Or even if you don't have an account on all of these things, you have a Gmail account. You're either connected, you're either reading newspapers from NRK at one point or the other. One of these services will ask you to make an account on them. And as soon as you make an account, it opens another world of possibilities on how you can use AI. And that's what's called content recommendation. So content recommendation is a pretty cool thing. What it means is that me as a user, if I have an account on Facebook and you have an account on Facebook, and even though we have the same friends, we are friends and we have the same circle of friends, after some while spending on Facebook, your wall or your feed on Facebook will be different from mine, because I will be clicking on different kind of links, you'll be clicking on different kind of links. So let's take another example. Let's talk about NRK or CNN or BBC News site. And your interest as a person would be different kind of news articles as mine. Some of our news articles will overlap, but after a while they will diverge and you will start looking at your own news. Now, when you click on each link and you read and you spend some time on each news article, what happens in the back end is that you have a lot of complex algorithms which keep on monitoring how you're spending time on each article. And then based on your age, your gender, the place you live, how much and some extra information, how much information you have provided them, and how many clicks you have done on certain articles, those algorithms start recommending you content which is suited for your needs. And this is one of the reasons why TikTok became so famous, because TikTok content recommendation algorithm is a very addictive one. You will, as soon as you log into TikTok, you have two tabs which are shown in front of you. One tab is your people you are following on a daily basis. And then there's other tab which is more like content recommended for you. And behind that, it's not one algorithm, it's thousands of algorithms which are monitoring you and trying to predict to you which video should you see next. And these content recommendation algorithms this is the smart part of AI, because this is where AI is used the most in social media companies. And for social media companies, this is their main IP or like their more intellectual property which they want to save. I don't know if you remember, but some while back, the US government, when Trump was in charge, President Trump was in charge, he forced TikTok to be sold to a US company. And they had a lot of negotiations being done, and everything was in order. And then China stepped in, and China said, okay, we will allow the sale to happen, but we will not allow the AI algorithm, the content recommendation AI algorithm, to be sold to any other country. And so this is how important they thought their AI algorithm was. They were like, we can sell everything around it. We can sell our users, we can sell our infrastructure, but we will not sell this AI algorithm. And then the US company said, oh, we can build a better algorithm than that. Of course you can, but this also shows how much investment is being done and how much pride people take in their AI algorithms. Yeah, so as I said, like content recommendation is everywhere on your App Store, Apple Store, the apps you see, the Google Play apps you see when you are on the streaming services, or if you are just on Google and you are searching for something and some search comes in front of you, those are also based on content recommendation, personalized to your specific feed. This is one of the major use cases of AI in my point of view. Okay, great. Okay, types of AI is very important for you to know, because this is something after ChatGPT came out, a lot of discussion was done on is being done on this AI side. I'll try to explain to you. For us, there are three types of AI. You have a narrow AI. So this is a narrow AI is something you work with on a daily basis. So you have a specific task and you want that task to be solved by AI, and you work with that one. So so let's say like um, Google Translate is more like general AI, but let's say like capacity prediction. You want to, oh, no, not capacity prediction. You want to predict if it's going to rain tomorrow or not. And that is an example of a simple task, one specific task. You take information of weather from the last few years, you put it to the AI model, and it will give you a prediction out of that one. That is called narrow AI. The second one is called general AI. Now, general AI is mostly like one algorithm which takes information from one area, transfers it to the other, and then makes a decision out of that one. General AI could also be called like multiple algorithms working in harmony and passing information to each other and making predictions. That would be content recommendation algorithm, which I spoke about earlier. It's not one algorithm, multiple algorithms working together. Now, super AI or artificial general intelligence is something which we are saying that if we are able to create an algorithm which is much smarter than humans, which can think on its own, and then actually we will not require any input or any maintenance from us at all. That would be super AI. And after ChatGPT came out, people started to think that ChatGPT was also super AI because it was thinking on its own. It was giving us answers, and people were scared. Like this ChatGPT assistance is thinking on its own, giving an answers. Is this an example of super AI? And then OpenAI came back and they said like, no, this is not super AI because this is its role. It's supposed to make up things, predict things based on what you have provided, and provide some feedback. That's the role. And they said this is not super AI. This could be an example of general AI, but not super AI. So we're not really there yet, but they are working hard to get there, which I think would be exciting. If we have an algorithm which is super AI, smarter than us, it will be great. So a question which I received on chat is that, sorry, what's happening? Yeah, a question I received in chat is, are chess bots super AI? No, I don't think chess bots are super AI. I would actually call them narrow AI, or there's a very thin boundary between narrow AI and general AI. Yes. Yeah, very good answer by Freya on that one too. Yeah, so I don't think they are super AI. Now, Turing test. We briefly discussed Turing test a few pages ago. What is a Turing test? So what Turing test says is that you have a person C, that's a person. A person C is standing in front of the wall, and the person does not know if it's a computer behind the wall, which is on the side A, or if it's a person behind the wall on side B. So this person which is standing on the C creates a question, writes down a question, and gives it to both of these people. And both of these persons have to reply to this question. Now, based on the answer, the person who's standing on the C side will be able to say if this is a if this answer which came to me is this coming from a person, or is this coming from a machine? And then they did this test with a lot of AI algorithms. So this became the standard. It's realized if a machine can pass the Turing test and fool a person into thinking that this answer actually came from a human, then we can say that this actually is a general AI, not super AI, general AI. Okay, we're still not going to the super AI part. General AI is still one step ahead. And what happened was that most of the machines were not able to pass this test at all, and we ended up calling them narrow AI, like the first basic type of AI. But then something happened like a few years ago when Google was working a lot on this AI algorithms, and they claimed like, okay, our AI algorithm has actually passed the Turing test. So Google was the first one to claim, and then ChatGPT came out, and ChatGPT passed it just like that. It was so simple for ChatGPT to pass it. So ChatGPT and most of the LLMs can actually pass the Turing test, and most of those LLMs fall into the general AI part. Now, if you try the same thing, and if you have an AI assistant present, and you try this with a friend of yours, and if you have Siri on your phone, or a Google Assistant. Well, Siri is really, I don't think Siri is to that technique. Siri is like, Siri, they claim it has AI, but it's like the most basic AI I've ever seen. Google Assistant is much more superior than Siri. So if you would like to do that test, try to do a test with a friend of yours and try to ask a question from a human, and ask the same question from the Google Assistant or any assistant you want to use, and try to see if which one of them are able to answer it in the right way, in a way you think it's actually coming from a human. And that would be your simple way of checking out if it's if that assistant passes the Turing test or not. A lot of chat is happening. Let me see. A very good point, that I'm not scared of a computer passing the Turing test. I'm terrified of one that intentionally fails it. Very good. And Siri is super AI. Okay. 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 Just comments. No question. All right. Good. I think, yeah, I have this. I don't know if you can hear this. I'm gonna play this YouTube video. This was a demo done by Google, and what they showed was that they made an AI system which actually made a call, and it fooled a person into believing that it was coming from an actual person. So let's see. I think I have to shut down my audio for you to be able to hear it.
How can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye. Okay, how may I hear you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people? When? Today?
Next
Tonight?
Wednesday at 6 p.m.
Oh, actually, we need to for like after like 5 people. For people, you can come.
How long is the wait usually to be seated?
When tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people. Okay.
Oh, I gotcha. Thanks.
Bye bye.
Okay. So that was a great example, right? This is an example of Google Assistant or Google of an AI assistant which is not able to act like a human, but also express some, like take the pause, uh, talk like a regular human, not like in a voice created by a machine. Like the way I'm talking to you right now, the way you'll be talking to me in a normal conversation, we will take pauses, we will think about words, and then we will we will have we will have a speech which is not a perfect speech, but that's how we normally talk in daily lives. And this is what was exciting about this presentation as well, that they were able to act like a normal human being. This is exciting. This was done in 2018. I mean, right now algorithms have become much more smarter. This is exciting because we're thinking about having our assistants who can do things on our behalf. But this is also very, very dangerous because we have a lot of spam calls. And US is one of the areas which has the biggest amount of spam calls. And the spammers use an actual human being. To think about, now this is where the ethics part also comes in. If someone tries to spam you by recording a voice of one of your family members, and you would probably trust a phone call coming from a random phone number. But if it's your mom calling or your dad calling and they're asking you for some help and they want you to immediately transfer some cash to the bank account, you would transfer the money without even asking for further verification. This has already started to happen. This technology is both being used in good and in the wrong way. So the people who are actually against the wide scale adoption of AI are actually saying that beware of the consequences, because obviously it can be used for good, but there are a lot of worse examples it can be used against for. Yeah. Okay. Yeah, okay. I don't know, I might be AI. On 13th of September, we'll find out if I'm AI or not. All right. So we spoke about 3 branches of AI, 3 types of AI, and now we're going to talk about 3 branches of AI. Not 3 branches, multiple branches of AI. Artificial intelligence. When you talk about AI, it incorporates everything. You have a lot of things going on in AI, but there are 2 important things in artificial intelligence. You have machine learning. We'll talk about machine learning more, where you actually program, machine learning is basically when you make an application and the application learns on its own, with its own experiences, historical information. And then you have deep learning, which is a more advanced version of machine learning. And we talked about neural nets, and yeah. Then you have a field which is not really AI, but like a sister field to AI, which is data science. It overlaps with AI in a way like you need a lot of data to be made available for AI algorithms. So this is a field which comes in and helps AI out. This is called data science. Natural language processing is a part of artificial intelligence. Natural language processing is why we have today ChatGPT, large language models, and these kind of things, which is on the side of natural language processing. Robotics is a field which is mostly mechanical in nature, but it uses a lot of components from AI. Yeah, and then images and yeah, okay, those are just like fields which originated from them. Okay, I think we are very close to the end. No, we're not. I think 1 or 2 slides more a minute. So, what kind of skills do you need to work with AI? You need to understand. Okay, people say you need to know math. Not really. We don't really use math on a daily basis when working with AI. Statistics, you need to know how statistics work. Because you need to know probabilities, you need to know this and that, and AI is built, everything is built on statistics. Machine learning, you need to know. You need to have like a deep understanding of machine learning for be able to work with AI. Statistical programming, sometimes, yeah, wouldn't say much, but software engineering is a must. Like machine learning is there's a very small amount of effort you put on machine learning, but the remaining of the work you put on general programming skills. Okay, we'll just skip this part. This is very important. The picture you see in front of you is a very common picture being used. Okay, how should I explain it? So, sex trafficking. Sex trafficking is one of the, it's a huge problem. People are kidnapped and they are actually forced into becoming sex slaves. And what happens is that then they have people who can control them. They take them to different places. They take their pictures and then they put them on sale, and then things happen. And yeah, so there's a separate. I mean, there's in every country, law, police department or secret service department has a division where they try to find those sex traffickers and they try to find the people who have been trafficked. So one of the ways they are actually catching those people is by looking at the pictures they upload to social media. So you have various kind of sites where you can buy and sell sex services, and you have a lot of people posting their own pictures over there. But you as a person don't really know if this other person is selling their services by their own consent or if they are being forced into it. So the law agencies have a very smart way of doing this. So what they do is they take a look at the picture itself which was uploaded. Now it turns out that most of the people who are forced into prostitution, they normally have the pictures being taken from a hotel. So they have their dealers who take them to a very nice background. It's mostly a hotel room because it is very nice in the background. And what they do is they download all the images. The law enforcement people download all the images and they run an AI algorithm. And then they try to identify which hotel this picture was taken from. Now, every picture has a specific layout, and they have a information available for all the hotels. And when they find the right match, they go to that hotel and they try to catch those people who come on over there. Now, this will not tell you if this is the person who is doing this on their own, or if the person is being forced into doing prostitution. But this is one of the ways they can identify where the business is originating from. And once they identify, okay, these people are going to this hotel, they then try to track them and see like, okay, this is a person who is doing it on their own, or this is like an agency behind who is kidnapping people and forcing them into prostitution. So this is the a nice use of AI, good use of AI, which should be encouraged more, and there should be more power available for these kind of use cases. So AI is used a lot of in money laundering as well. Have you ever like tried to open a bank account and the banks were like, okay, we need more information and we need to do blah, blah, blah. And one of the reasons they do this is because their algorithms kind of highlighted you as a potential threat and they want to ask you more questions. And a lot of, so these, a lot of AI is used in the backend. Terrorism. So, I mean, there are thousands of use cases in terrorism where AI is used. But one interesting use case I want to share with you, since this kind of relates to me, there's an app called Muslim Pro. Muslim Pro is an app which is used by a lot of Muslims around the world, which tells them the times of the prayer. This is the de facto app which any Muslim will have. And what happened was that after the 9/11 attacks, around 2009, 2011, when there was a huge war going on with Afghanistan, this app was, of course, being used by Taliban as well. And what this app started doing was it started selling its data back to the U.S. military government. So as long as the data was coming from the Afghanistan side, everything was fine. But then they kind of increased their radius as well. So then they started selling data on Muslim movements around the world. And they were selling it to another third company, which was selling it to the US military government. And it took like 5 years before people found out, oh, our data, this is a free app, but our data is actually being sold to the US military, who can actually use this information and know at any given point where we are. We're going from one place to the other. They know where we're going. And this is being used to, okay, in a good way to reduce terrorism, but in a bad way also to target people who just want to like kill, for example. So that is also bad use of AI, getting data from illegal ways. In COVID-19 research, when COVID happened, a lot of focus was put into how AI could predict the disease before it could happen. A lot of research was done into stopping COVID, but this is not really how AI works. But at least a lot of researchers were able to identify that, okay, if we had used this algorithm 2 years ago, we would have identified this strain from even spreading. Now we have those checks and balances in place. So we have done that research, and I'm hoping that we're going to use this in a practical way. Okay. I am going to stop now, and let's look at the questions. Okay. Okay, this is just conversation between all of you. That's fine. Oh yeah, sorry. Very good question about the lab. So we have a lab tomorrow. That will be the first lab. Please go to. You can either go tomorrow or you can go day after tomorrow. So you will have a lab assistant. You'll have 2 lab assistants who will help you out, and they will help you with the labs. So if you want, you can start working on the labs on your own. It's already uploaded. Take a look at them and ask questions if you need any help. Today's class is over. So that was it from my side.
I have a question.
Yeah, sure. Go ahead.
Are all of the lectures going to be only like pictures with a little text, or?